Man, I'm so proud of my achievement, from a depressed college student to the owner of my very own bank, and I made my own vault to my specifications with 150 feet, and I only had to make 3 walls.
Jamie has enough walling to make 150 feet of wall for a new vault in her bank. The new vault is being put next to an already existing wall so that only 3 sides to the vault need to be built. Jamie found that the width needed to be 37.5 feet and that the length had to be 75 feet for a total area of 2,812.5 feet squared. She also checked the max to make sure that this would maximize the area of her vault.
Wow, all this hard work. And look at my beautiful vault. What? Not my vault? We'll get to the bottom of this, ma'am. Don't you worry. Any idea who did this? He did it. That guy right there. I'm on the case.
Our story continues with a supersonic chase into the woods. The two characters, our beloved cop James and our evil villain David, continue running to determine the fate of the poor banker James.
The woods. Oh, fiddlesticks. I know that there are some of those gosh darn bears in here. Let me think. There are...
The population of bears in this forest is modeled by dp over dt equals 0.05 parentheses 1 minus p over 10 close parentheses. So therefore, 10 is the carrying capacity. The forest is 1,582.7 square miles. Then there are about, let me think, 0.006 bears per square mile. So therefore, I'm only gonna run a mile. So therefore, there's a little chance that we'll see a bear.
There's no way I'm gonna run into one of those bears. The probability is too low. Oh gosh darn fiddlesticks. I could go find somewhere to hide.
Oh, heck no.
There's a bear chasing me. I need somewhere to hide. Do you see somewhere to hide?
On your left.
On the what?
On the left.
On the right?
This kid gonna die.
Oh, thank the Lord and call me daddy. A trash can.
Just by looking at the trash can, David could see, obviously, that the radius at the bottom of the trash can was 1 foot and the radius at the top was 1.5 feet, and the height was 3 feet. Therefore, he knew that the equation to represent the sides of the trash can was y equals 6x minus 6. However, since the trash can was vertical, he needed to rotate it around the y-axis, so he changed everything into terms of y to get x equals 16y plus 1. Then he integrated using volume of revolution from 0 to 3 feet as the height, and got the volume of the trash can to be 14.9226 cubic feet. But however, he wanted to know if he would fit inside. He knew that if he crunched up into a ball shown by this picture, he will have a height of 3 feet and a radius of 1 foot representing a cylinder. He then found the volume that he would take up, which was 3 pi cubic feet. Since the volume of the trash can is bigger than the volume of itself, he'll fit.
Time to escape for real this time.
Our evil villain and good-for-nothing robber that doesn't do anything with his life and is a plague on humanity, David, has lost our loving cop James in the woods. Is there any hope for justice anymore?
Even though I escaped the woods and lost the cop, I need to escape somehow. Oh look! A car! It's still running! That guy goes to Chapel Hill, what an idiot. Dang nabbit. I gotta be quicker than that.
I got you now, you son of a biscuit.
Booey! I'm gonna have to jump that lake off that cliff.
Will I make the jump though? I know that the cliff is 3 meters tall and will launch me at an angle of 30 degrees. I also know the equation for projectile motion. However, will I make the 250-meter jump across the lake even though I am raised 3 meters above at an angle of 30 degrees? I'm about to find out. The speed I need to make it is 118.6 miles per hour, 53 meters per second. That's a crazy high speed. I don't think I can make that. However, if I am going 118.6 miles per hour, I will reach a max height according to this. If I plug in the numbers that I know, set the derivative equal to 0, and then solve for t, I will be at the max height at 2.704 seconds. And I know that's a max height because the second derivative is negative, so it's concave down, and therefore it is a max height. So if I plug 2.704 seconds, the time at max height, into the y vector equation again, I will have a max height of 38.829 meters. The actual speed of my takeoff is 60 miles per hour or 26.8224 meters per second. So how far will I actually go? Well, if I plug in my numbers into the y component and I set it equal to 0, that'll find the time of impact with the lake. I will impact the lake at 2.945 seconds. How far will I go though? Well, if you plug into the x component the time of 2.945, which is the time of impact, and plug in the numbers I know, I will get 68.406 meters across the lake. That's not even a third of the way across the lake. I'm gonna die.
Dang nabbit, I'm not actually gonna make it. I should have done the math before I jumped.
He should have paid attention to his calculus. Drats. I guess I didn't get him. The demons will be his cellmates now. Wait, maybe I can still save him.
David's vehicle is landed in the lake. The water is spilling into David's car at a rate of 50 feet cubed per minute. Assuming the car is a rectangular prism that is 10 feet long and 4 feet wide, what is the rate at which the height of the water is rising? Thereby, if the water rises 1.25 feet per minute and his car is 5 feet tall, then it would have taken 4 minutes for his car to fill up. I've been standing here for 10, so I guess he's dead. Oh well.
Oh, never mind. He will surely be dead before I can get there. Rip your boy DZ.
I'm alive. I knew all those scuba diving lessons would pay off.